Hello friends, welcome back to my video series which is on plus 2 class physics. So friends, in previous video we discussed the general idea of electrostatic, in which we define the Coulomb's law and we explain various properties about the charge, and at last we study charge distribution. Friends, in this video we will explain following topics which you can see in your screen. Friends, in this video we will explain first 5 topics, and next 5 topics will be covered in next video. So friends, let us start. Friends, firstly, in this video we will define electric field. Electric field is a region of space around a charge or a system of charges within which other charged particles experience electrostatic forces. Friends, this we can understand by figure. Suppose we have positive charge, so that it has a region around it or space within which it can exert force on other charge. Suppose I move small charge q naught to this bigger charge. So when I come this charge closer this bigger charge, then at this point where bigger charge field start, then this test charge q naught will experience a force. So here we can easily prove that this bigger charge have field or space which start from here, in which it will exert force on other charge. And in place of bigger charge there may be system of charges. Suppose this is system of charges. Now they have a field and they occupy a space in which this field exists. If I move small test charge to this system, and similar effect I can observe at the boundary of electric field of this system. Now friends, theoretically electric field extend up to infinity, but practically it is limited to a certain distances. It should be remembered. Now friends, we will explain electric field strength or electric field intensity, or simply electric field. We will define electric field. What is electric field? Friends, electric field is defined as the electrostatic force per unit positive charge, which we consider q naught, and this test charge q naught we choose so small. Reason for this will we explain later. So friends, electric field is equal to force per unit charge. This is the mathematical definition of electric field. Electric field strength at a point in electric field is the electrostatic force per unit positive charge acting on a vanishingly small positive test charge placed at that point. As we have seen in this case, this is region of electric field of this charge, and suppose we have a small test charge q naught, and this charge is vanishingly small, means it vanishes to zero. Actually not zero, but very very small. As we can see in figure, there is a charge q naught plus q, positive charge, and here we have placed a test charge, positive test charge. So friends, how we can determine whether charge creating field around it is positive charge or negative charge? This can be understood by this figure. In first figure, we can see that force acting away from test charge. Friends, this definition should all be kept in mind, that to test electric field, we use small positive test charge. Small positive means positive test charge should be positive. This is the first condition. So if we have not any information about this charge whose electric field is to be determined, then as we have known about our test charge, and also in previous video we also understand about the force between two charges. If two charges were like charges, means same charges, positive negative negative or positive positive, when these two charges were like charges, then force will be away from each other. Electrostatic force was away from each other. In other case, when these two charges was unlike charges, means one is positive, other is negative, and vice versa, then electrostatic force was not away from each other, but they attract to each other. So using this knowledge, we can easily understand what kind of charge is there which creating field. So in this case, when there was positive charge and we keep moving this test charge q naught toward this, then at a point of field of this charge will experience repulsion. So we can easily confirm that this charge which creating field is a positive charge. And in other case, when this charge was negative charge, and on entering this test charge in the field of this charge, this will explain attraction toward this charge. So this will confirm there is negative charge which creating field. Now friends, this is the mathematical definition of electric field. Electric field is equal to limit delta q tends to 0 F divided by delta q. Friends, as we describe in definition, that test charge should be vanishingly small. So we take here limit delta q tends to 0, means that test charge should be very very small, such that it should be very near to 0. And we take ratio of force to that charge. This will give electric field. Or simply we can write this as is equal to F to the Q naught. Friends, as we know that F is Coulomb force between these two charges, or this, which we know that from Coulomb's law, that was force between two charges were 1/4 pi epsilon naught product of charges over distance between them. In this case, force between two charges is 1 over 4 pi epsilon naught, and product of two charges, first charge is q and second charge is q naught, and distance, let us suppose that distance between these two charges is r, that is r square. Now friends, using this definition of electric field, force per unit test charge, that is q naught, that is electric field can be given as E is equal to F over q naught is equal to 1 over 4 pi epsilon naught q into q naught over test charge, which is q naught. This will cancel out, and hence we are left with electric field 1 is equal to 1 over 4 pi epsilon naught q over r square. So friends, this will be electric field. This should be remembered that in Coulombic force between two charges, it was depend upon product of charges and inversely proportional to square of distance. But in electric field, constant is as it is, and this is equal to ratio of charge to the square of distance between them. This fact should be remembered, and in this fact we should not confuse. Friends, in vector form we can write electric field like this by placing a unit vector, which simply shows the direction of electric field. Friends, reason for the fact that we were using here a small test charge to check the electric field is here, that is, the test charge is considered to be vanishingly small because its presence should not alter the configuration of the charge and thus the electric field which is intended to be measured. Friends, suppose that if this positive charge we use is high as compared to this charge, then obviously it will create its field around itself, since we have to check this field of given charge. So in this case, this will not give the proper measurement of the electric field of this charge. So bigger charge can alter the configuration of the charge, and hence this charge should be smaller, which tends to 0, so that its own field is very small, which can only experience the force of other charge. So friends, this was the reason about this fact in which we can use smaller test charge particle. Friends, let us proceed further. Here is some note. Since Q naught is taken positive, the direction of electric field is along the direction of electrostatic force. Friends, this fact can be understood as if we have two charges, one is positive and other is also positive. This is one case. and this positive we keep as it is, and other charge is negative. Then what is difference? As we can see, these first is like charges, then electric field or force will be away from each other. In second case, these are unlike charges and they will attract to each other. So force will be like this. So electric field will be in the direction of force, electrostatic force. Second, electrostatic force on an actively charged particle will be opposite to the direction of electric field. As we can see here, this is an actively charged particle. Electrostatic force on this charged particle will be opposite to the direction of electric field. So this is direction of force and electric field will be opposite to the direction of electrostatic force. This will be electric field. So friends, this will be electric field in negative charge case, and in positive charge case electric field will be in the direction of electrostatic force. So if this is direction of force, electric field will be in same direction. Now third one is electric field is a vector quantity whose magnitude and direction are uniquely determined at every point in the field. So friends, if this is the electric field or simply field, then electric field at any point can be given as tangent to that point. If I want electric field at this point, then I will draw tangent at this point, and magnitude and direction at these respective point will be different. So electric field is vector quantity whose magnitude and direction are uniquely determined at every point in field. As we can see, direction are different and their magnitude will also be different. SI unit of electric field is Newton per Coulomb. As initially we explained definition of electric field as force per unit charge. Since force has a unit of Newton in SI system and charge have Coulomb, so SI unit will be Newton per Coulomb, and corresponding dimension formula can be determined. Since force have dimension formula ml t minus 2, and charge, since we know that I current is equal to charge over time and q is equal to charge into time, current into time. Since current is fundamental quantity and have unit SI unit as ampere, and time have unit second in SI system, so in dimension formula we can write this AT, and using here AT, then this will cancel out with this, and dimension formula of electric field, we are left with ml t minus 1 t minus 1 ampere. So this will be dimension formula of electric field. So friends, let us proceed. Electric field due to a point charge. Now we will determine electric field. Now friends, we will consider a positive charge plus q at origin here, and we will consider a small positive test charge plus q naught at point P, which is at x, y, z. Let us suppose that distance between these two charges is given by vector r. Now as we can see that these are two positive charge, and electrostatic force will be away from each other. Or if we are, as we are interested in the electric field of this charge, we will check from this test charge. So when this test charge enter the region of electric field of this positive charge, this will experience a repulsive force which will be in this direction. Now friends, as we know that Coulombic force between these two charges can be given by this expression. Since we know that r is unit vector and can be given as vector r divided by its magnitude. So using this value here, we will get this expression. Since electric field is this one, force per unit test charge, this can be get by simply divide this electrostatic force by q naught. Using this, then this q naught will be cancelled out, and we will left with this expression. This will be electric field of point charge, or this can be written in unit vector form by separating from here r vector to the r and writing in its place simply r unit vector, which is done here. So friends, electric field due to point charge has spherical symmetry. This should be remembered that if I have point charge, then its electric field will be spherical symmetry. That is like a ball. So point charge will be represented by a ball. Electric field due to point charge has spherical symmetry. Friends, it should also be remembered that if I have positive charge, this is very important point and should be used several times further. So friends, if we have positive charge, then electric field will be radially outward. This is radially outward. Radially means this is spherical charge, this will be radially outward here. So positive charge have electric field which is radially outward, and if I have negative charge, its electric field will be radially inward, means electric field will act like this. So friends, this point should be noted. Let us proceed further. Now we will describe electric field in terms of coordinate. Friends, in terms of coordinate, as this can be given by as if I have this coordinate system and this is point P where I have positive test charge Q naught. This is coordinate system, that this is X, this one is Y, and this X is Z. Then this has point X, Y, Z. And here was that positive charge whose field is to be determined. And this distance can be represented by vector R. Since as we know that vector R can be represented by this, that is xi cap plus y in j direction plus z in k direction. These are distances, means this x is distance along x direction, y is distance of this particle test charge in y direction, and this is distance of charge particle in z direction. So this is r vector. And what is magnitude of this vector? Magnitude of this vector is simply square of these distances under the root, means magnitude of this will be x square plus y square plus z square under the under root. So friends, you can see here ER is equal to 1 over 4 pi epsilon naught q over x square plus y square plus z square power 3 by 2 x I cap plus y j cap plus z k cap. Since we get this by simply using these value which we describe, as f was, let we write for this constant k, and so we are defining electric field. Let we write this k for constant 1 over 4 pi epsilon naught, and here is q, and in numerator we have vector r in form of vector form, and in denominator we have r cube. Now using these value which we define, k q, r vector was x I cap plus y j cap plus z k cap divided by r cube. And what was r? R is magnitude, r was magnitude which was x square plus y square plus z square under the root. Root means 1 by 2, and there is cube power of this, and means this will be multiplied by cube, that is 3, and we have this as 3 by 2 at denominator. So this will be electric field in term of coordinate.